Welcome students, and today in exercise 1.1 we are going to see sum number 8. So here you see adjoint of A is given and you are asked to find A. Usually A will be given and you are asked to find adjoint A, isn't it? Now it is given in reverse. Adjoint of A is given and you are asked to find A. If so, we have to use a different formula. So solution, to find A, the formula is A is equal to plus or minus 1 by root of determinant of adjoint A into adjoint of adjoint A. A is equal to plus or minus 1 by root of determinant of adjoint A into adjoint of adjoint A. So first we have to find determinant of adjoint A. So determinant of adjoint A, so I have written the determinant of the given matrix. Okay. Now you know how to find the value. So 2, leave the row and column. 12 into 2 is 24, minus 7 into 0 is 0. Change the sign of this number, which is plus 4. Leave the row and column. Minus 3 into 2 is minus 6, minus 2 into minus 7 is 14. So 14. Plus third number 2, leave the row and column. 3 into 0 is 0. Minus 2 into 12 is minus 24. So therefore it is plus 24. Now 2 into 24, 4 into minus 20, 2 into 24, which is 48 minus 80 plus 48, which is equal to 16. Now we have to find what? Adjoint of adjoint A. Okay, we have to find adjoint of adjoint A. Now to find adjoint of adjoint A, you know how to do it, isn't it? Just put the sign like plus minus plus, minus plus minus, plus minus plus. Okay. Now the first number, we leave the row and column. 12 into 2 is 24, minus 0 into minus 7 is 0. Then second number, leave the row and column. Minus 3 into 2 is minus 6, minus 2 into minus 7 is minus 14. Third number, leave the row and column. 0 into minus 3 is 0, minus 2 into 12, so it is plus 24. Now second row first element, so leave this row and column. 4 minus 4 into 8 is minus 8, minus 0 into 2 is 0. Middle element, leave the row and column. 2 into 2 is 4, minus 2 into 2 is minus 4, so it is plus 4. Then the third element, leave this row and column. 0 into 2 is 0, minus 2 into minus 4 is 8. Then third row first element, leave the row and column. minus 4 into minus 7 is 28, minus 12 into 2 is 24. Then second element, leave the row and column. 2 into minus 7 is minus 14, minus 3 into 12 is, minus 3 into 6 is minus 6, so it is plus 6. Then the third element, leave the row and column. 2 into 12 is 24, minus 3 into 4 is minus 12. Okay, so now you have to find the transpose of this element. So which is 24, 6 minus 14, minus 6 minus 14 is 20, that is a minus, that's why. 24 and minus 8, so there is a minus, so plus 8, this is plus 8, this is minus 8, there is a minus, so plus 8. 28 minus 4, 24 is 4, minus 16 plus 6 is 8, there is a minus, sorry, minus 8, there is a minus, so plus 8. 24 minus 12 is 12. Find the transpose of this element and the transpose value is written here. Now you can see here in this particular matrix, you can take common element outside. Now see, what is the common element we can take outside is 4, isn't it? From all the elements we can take 4 outside. So taking 4, you have got 6, 2, 1, 5, 2, 2, 6, 2, 3. Okay. Now applying the formula, which is plus or minus 1 by root of determinant of adjoint A. So adjoint of A, so far we have found, which is 16. So root 16 into this matrix. Root 16 is 4. So 4 and 4 will be cancelled. So plus or minus, and this is the answer. Exercise 1.1, sum number 9. Here adjoint of A is given and you are asked to find A inverse. Suppose A is given and you are asked to find A inverse, means It's very simple, but adjoint of A is given. You know the formula for A inverse is 1 by determinant A into adjoint A. Adjoint A is already there, but to find the determinant of A, we don't have any value. So we can use this formula. Okay. So A inverse is equal to plus or minus 1 by root of determinant of adjoint A into adjoint A. It's very simple. So find only the adjoint A and write it, and write this adjoint A value here. That's all. So determinant of adjoint A I have written here. See here, this is 0. So you can leave the row and column, and multiplying and writing the value is also 0. So you can simply leave it. So this is 0. I have put 0 here. Second element, change the sign. Minus 2 becomes plus 2. Leave the row and column. 6 into 6 is 36. Minus 3 into 6 is 18. So minus 18. So 36 minus 18 is 18. 18 into 2 is 36. And A inverse is equal to what? Plus or minus 1 by root of determinant of adjoint A. Determinant of adjoint A is 36. So root 36 into the adjoint A matrix is written here. Okay. So root 36 is nothing but 6. So plus or minus 1 by 6 into the given adjoint A matrix. And that's all. This is the answer. Exercise 1.1, sum number 11. A matrix is given, which is a 2 by 2 matrix, and you are asked to show that A transpose into A inverse is equal to a given matrix. Okay. So first of all, here we are going to find A inverse, right? You know how to find A inverse. A inverse is equal to 1 by determinant A into adjoint A. So determinant of A, I have written the matrix. So 1 into 1 is 1, minus tan x into tan x is minus tan square x, so it is plus tan square x. You know that 1 plus tan square x is secant square x in trigonometry identity, so we can write it as secant square x. Now A inverse is equal to 1 by determinant A, which is secant square x, into adjoint A. So to find, how will you find adjoint A? You have to interchange the two elements. So 1 and 1, change the sign of this, so it is minus, change the sign of this, so it is plus. Okay, so now this is A inverse. A transpose, simply transpose this and write. So I have transposed it, and you can write. So this minus tan inverse go there, and minus tan x goes there, and tan x will come here. So that is written. A inverse is also written here. Okay. Now this 1 by secant square x can be brought in the front. Okay, and these two matrices are written nearby. Now we have to multiply it. So 1 into 1 is 1, minus tan x into tan x is minus tan square x. 1 into minus tan x is tan x, minus tan x. Minus tan x into 1 is minus tan x. 1 into tan x is tan x, and 1 into tan x is tan x. Tan x minus tan x is minus tan square x. 1 into 1 is 1. Okay. So now here this tan x and tan x plus tan x is 2 tan x. Minus tan x and minus tan x is minus 2 tan x. Okay, right. Now this cos square x has to be taken inside. So this cos square x has to be multiplied with this element, this, and also this. Here we have two separate terms. So here and also here we have to multiply. So 1 into cos square x is cos square x minus cos square x into tan square x. Here this is minus 2 tan x. So cos square x is written here. This is plus 2 tan x. So here also the cos square x is written. So here cos square x into tan square x. So minus tan square x into cos square x plus 1 into cos square x is cos square x. Right. Okay. Now you can split this tan square x. Like tan square x can be split as sin square x by cos square x. And here also tan square x can be split into tan x is split into sin x by cos x. Here also tan x can be written as sin x by cos x. Here also tan square x can be written as sin square x cos square x. Okay. Now see here, this cos square x and this cos square x is cancelled. So cos square x and minus sin square x. Here cos x and the square is cancelled. So minus 2 sin x and cos x is written here. Here also cos square x and the square is taken away. So 2 sin x and cos x. Here the same thing, cos square x and cos square x is cancelled. So cos square x minus sin square x. And you know that cos square x minus sin square x is cos 2x, and 2 sin x cos x is sin 2x. There is a minus, so I have written the minus. Same way here, 2 sin x cos x is sin 2x, and cos square x minus sin square x is sine 2x, and that's all. Now, an interesting application of matrix is cryptography. The cryptography, I'll explain with an example. The person 1 and person 2, the two persons are exchanging information between them in a secret manner. So from person 1, a message is sent to person 2, or from the person 2, a message is sent to a person 1. Whatever it might be, the person's messages, two persons messages will be a secret communication. No other people can be revealed the message. And how it can be done? It means from message sent from person 1 should be encrypted. It means converted into an unknown format and sent away. And when that message is received into person 2's when that message is received by person 2, here that message will be again decrypted. That means it will convert it into original thing. And how we can do with the help of matrix, we are going to see. So see here, person 1 send us message. Okay, that is now taken converted into a matrix, and that will be multiplied by a encryption matrix. Consider as A matrix. So sender's message into encryption message will give you another matrix which is called as encoded message, and this will be sent from the person 1, maybe mobile or whatever it might be. Now when this encoded message reaches the person 2 mobile, that will be converted into back to the original message by multiplying this encoded message by a decryption matrix. So this decryption matrix is nothing but maybe A, this is A means this can be A inverse. So encoded message into decryption message will give you the receiver's message, the original message. Okay, for example, this is hello means when you multiply this hello message with the encryption message, you will get some different message, and that will be multiplied with the decryption matrix, you will get hello back. So using that, we are going to solve this sum number 15. Sum number 15, you see, decrypt the received encoded message. Okay, so from person 1, maybe we can consider like that. This is the message, this is a converted message sent from person 1. Now we have to find this message. So this encoded message has to be multiplied with the decryption matrix. They have given this is as encryption matrix, and decryption matrix is nothing but inverse. So this is A means we have to find A inverse and multiply A inverse with these two matrices, and we will find the answer. And they have given one more information, that codes, how will you convert the messages means for numbers 1 to 26, we will take it as A to Z. Okay, matrix, when you have, if matrix is a collection of numbers of 1 to 26, we have to make it as A to Z, and 0 means blank space. I will explain this little later, that means at the end of the problem. Now coming to the solution. Now see, this is A matrix. To find the decryption matrix, we have to find the inverse. So A inverse is equal to 1 by determinant A into adjoint A. So I'm going to find the determinant A. So determinant A is minus 1 into 1 is minus 1, minus 2 into minus 1 is minus 2, so which is plus 2, which is 1. Now A inverse is equal to 1 by this 1 into adjoint A. So interchange the two element 1 and minus 1, change the sign plus 1, change the sign minus 2. Now this is A inverse. This A inverse, this is the decryption matrix. This matrix must be multiplied with these two matrices. So first I have written this matrix here, and I am going to multiply with this A inverse. Now this is the first matrix, and this is the A inverse decryption matrix. We are going to multiply. 2 into 1 is 2, minus 3 into minus 2 is plus 6. 2 into 1 is 2, minus 2 into minus 1 is plus 3. So we have got 8 and 5. Okay. Now second matrix and the decryption matrix. 20 into 1 is 20. 4 into minus 2 is minus 8. 20 into 1 is 20. 4 into minus 1 is minus 4. So 20 minus 8 is 12. And 20 minus 6 is 16. So now in the question it is given that number 1 to 26 is A to Z. So I have written like A, B, C, D till Z, and I just numbered it from 1 to 26. And space means 0. So here we have got the value 8, isn't it? So equivalent of 8 is H. So the first letter is H, second letter is 5, equivalent of 5 is E, and third letter is 12, equivalent of 12 is L, fourth letter is 16, equivalent of 16 is P. So the receiver's message is nothing but HELP, help. Exercise 1.1, last sum number 14. If A is a 3 by 3 matrix, show that A inverse is equal to 1 by 2 into A square minus 3i. So how we are going to do this problem? A inverse is equal to 1 by 2 into A square minus 3i. So you can do it as we have seen. We know that A inverse into A is equal to I. So I am going to make this as I. To do so, pre-multiply by A on both the sides. So A we will multiply on the left hand side as well as on the right hand side. So right hand side we have two terms, so here and also here. So A square pre-multiplied by A and I is pre-multiplied by A. A into A inverse is nothing but which is I, and this A into A square is A cube, and A into I is A. Bring this 2 to the left hand side, it becomes 2i which is equal to A cube minus 3A. So we can prove this is enough. So now we are going to find A square, then we will find A cube. A square is A into A, so A matrix into A matrix. 0 into 0 is 0, 1 into 1 is 1, 1 into 1 is 1. 0 into 1 is 0, 1 into 0 is 0, 1 into 1 is 1. 0 into 1 is 0, 1 into 1 is 1, 1 into 0 is 0. 1 into 0 is 0, 0 into 1 is 0, 1 into 1 is 1. 1 into 1 is 1, 0 into 0 is 0, 1 into 1 is 1. 1 into 1 is 1, 0 into 1 is 0, 1 into 0 is 0. 1 into 0 is 0, 1 into 1 is 1, 0 into 1 is 0. And 1 into 1 is 1, 1 into 0 is 0, 0 into 1 is 0. 1 into 1 is 1, 1 into 1 is 1, 0 into 0 is 0. So we have got 2, 1, 1, 1, 2, 1, 1, 1 and 2. Now we have to find A cube. A cube is A square into A. So A square into A matrix. So 2 into 0 is 0. 1 into 1 is 1. 1 into 1 is 1. 2 into 1 is 1. So 2 into 1 is 2. 1 into 0 is 0. 1 into 1 is 1. 2 into 1 is 2. 1 into 1 is 1. 1 into 0 is 0. 1 into 0 is 0. 2 into 1 is 1. 1 into 1 is 1. 1 into 1 is 1. 2 into 0 is 0. 1 into 1 is 1. 1 into 1 is 1. 2 into 1 is 2. 1 into 0 is 0. 1 into 0 is 0, 1 into 1 is 1, 2 into 1 is 2, 1 into 1 is 1, 1 into 0 is 0, 2 into 1 is 2, 1 into 1 is 1, 1 into 1 is 1 and 2 into 0 is 0. Now 1 plus 1 is 2 and 2 plus 1 is 3, 2 plus 1 is 3, 3, 2, 3, 3, 3 and 2. Now finally we have to find A cube minus 3A. This is A cube minus 3 into unit matrix. So it becomes, bring this 3 and multiply inside. So it becomes like this. So 2 plus 0 is 2. 1 minus 3 is, 3 minus 3 is 0. 3 minus 3 is 0. 3 minus 3 is 0. 2 plus 0 is 2. 3 minus 3 is 0. 3 minus 3 is 0. 3 minus 3 is 0. 2 plus 0 is 2. Right? Now you see here, 2 is the common element, isn't it? So I can take the 2 outside. So it becomes 1, 0, 0, 0, 1, 0, 0, 0, 1. You know that this is nothing but what it is, a unit matrix. So 2 into I. So 2 into I is, we prove that A cube minus 3A which is equal to 2 into Y. Therefore, A inverse is equal to 1 by 2 into A square minus 3A. And that's all. Thank you.